All right, section 14 notes. I can solve a system of linear equations using substitution. Substitution is where we replace. First of all, look for an equation with one variable solved for. Now there can be two equations that are solved for one variable, but you have to have at least one. Look for an equation with one variable solved for to do substitution. Now, this is an old concept. This is something you've already done, Algebra 1, so this shouldn't take you a long time. We will replace one expression into another equation. So let's take a look at examples here of doing that. Now, in this first example, you can see that I literally can take this and put it in here, creating 2x minus 3 equals 5x plus 6. Now, we're going back to our Algebra 1 skills, moving variables to one side, moving constants to the other. So we're subtracting a 2x, we're subtracting a 6, and getting negative 9 equals 3x. And then we can keep going with this whole process, dividing by 3, get an x value of negative 3. Now, what do I do with that once I find it? I get to plug it into an equation to find the y value. Can I do it to either equation? And the answer is yes. And in this case, both equations are solved for y, so pick your favorite one. So let's say you pick the first one, 2 times negative 3 minus 3. That tells me negative 6 minus 3 is negative 9. So, a lot of times I'll ask in class, is this the same point as negative 9, negative 3? And of course the answer is no. This is the wrong point. We want negative 3, negative 9. Now, what are we actually finding? Hold on a second. I'll pause and show you what we're actually finding. So when we go over to Desmos, the graphing calculator, and we graph these two equations, what are we finding? Boom, the intersection point of the two lines. And yes, negative 3, negative 9 is definitely different than negative 9, negative 3. So, highly important that you put them in the correct spots. But that's what we're actually finding, the intersection point. We've talked about that on a different day, but just thought I would emphasize that again. These are not just random numbers of the universe. These are locations, and locations are important. Let's go to the next example. We can clearly see that one of the equations is solved for. It's solved for x. So I'm going to be replacing the x in the first equation with a 4y or 4 plus 5y. And then starting this process of distributing, right? 12 plus 15y minus 6y equals negative 6. Of course, these things over here are 9y, and then we need to move things to the other side, right? So, for instance, the 12 will move to the other side, so I'm going to subtract it, getting negative 18 equals 9y, and then dividing by 9 on both sides. And so we end up with y equal to negative 2. Okay. Now, is there an equation to plug it back into? Yeah, you can plug it into either one, but doesn't this one look a little bit nicer? Because it's already solved for x. I can just 4 plus 5 times negative 2, and then I've got 4 minus 10, or negative 6. So now I know what x equals, and the coordinate negative 6, negative 2 is the solution where the two lines are crossing. And now we'll go to the next example. All right, so this one obviously set up, ready for y. We're going to substitute. We're going to put it in here right below. You could see, so I'm going to rewrite this equation, 3x Instead of writing y, we're going to put negative 3x minus 8 equals 10. Okay, well, what do I notice that immediately happens? Those two things cancel out. I get negative 8 equals 10. All right, next question. In your lifetime, when has negative 8 been equal to 10? Options are always, sometimes, or never. Now, we all know the answer to this question is never. Negative 8 is never equal to 10. If you think that's true, probably should make sure you get a good accountant because you might end up in jail. All right. But evidently, the federal government thinks that negative numbers are pretty good. So, maybe that's just the way it should be. No, definitely not. All right. So, this is never true. What does that mean? That means there is no solution. Now, what does it mean for my lines? It means my lines never cross. So that must mean we have parallel lines. Okay, so two lines that have the same slope, all that good stuff that we've talked about for a long time, geometry, algebra. Okay, once again, ready for substitution. This is going to get replaced for that x right there. So we have 4 parentheses 5y plus 3 minus 20y equals 12. So we can distribute and get 20y plus 12 minus 20y equals 12. Oh, look, the 20y's cancel, leaving me 12 equals 12. Okay, same question. When has 12 ever been equal to 12? Choices are always, sometimes, or never. And of course, we know the answer to that question, always. So, what does that mean? Well, it means that the two lines are exactly the same. You got one line sitting on top of the other line, means that all points are solutions. Well, wait a sec. A line goes on forever and ever in both directions, never stops. This means we have an infinite number of solutions. So you've heard the expression infinitely many. Why is it doing that? Many solutions. And so a lot of times you will see teachers abbreviate that IMS. Okay? Infinitely many solutions. But I'm going to go one step further. Your answer better say infinitely many solutions on, and then you actually have to name the line. What do you mean, Mr. Stailey? You actually have to give the name of the line. It's not just any random infinite points out there. There's lots of points that are not solutions to these. But if you say infinitely many solutions on x equals 5y plus 3, that's a good answer. If you said infinitely many solutions on 4x minus 20y equals 12, that would be a good answer. But you can't just randomly say IMS and then you're done. You need to name the line. So, if you want full credit, you better be naming the line. Thank you. All right, let's go to the next example. So a company spends $12,000 for football. This is what we call a fixed cost. That's not going anywhere until we pay it off, obviously. It's also not changing. Each football costs $3 to make. So if we come up with a cost equation, the cost equation is going to be $3 for every football plus, not $2,000, $12,000 for fixed costs. Well, the revenue, this is, can't spell. Revenue is how much money you make. We make $9 every time we sell a football. So the question is, set up and solve a system of equations to determine how many footballs the company must sell to break even. That means back to zero. See, right now we're at negative 12,000. We literally spent $12,000 and we want to get from negative 12,000 back up to zero. And then we want to keep making more footballs after that and make more money. So this is a great situation for the substitution, right? Because now I can do this and substitute here. So we have 9x equals 3x plus 12,000. And the 3x can go to the other side, giving me 6x equals 12,000. And you can divide by 6 on both sides to find out that we need to sell 2,000 footballs. 2,000 footballs. Now, each time we've been doing these questions, once we found one value, we plugged it back in to figure out what the other one was. But they never asked me how much money would I have brought in revenue. So I'm not going to worry about it. In this particular situation, I only needed the number of footballs, and this would get me back to zero. So once we sell more than 2,000 footballs, we'll be making money. And obviously, we'll be making $6 every time we sell another football. Okay, Carson is a songwriter who collects royalties on his songs whenever they are played in a commercial or a movie. Carson will earn $20 for every time one of his songs is played in a commercial, and he'll earn $120 when it's played in a movie. Carson's songs were played, so it looks like we made $380. And then it says Carson's songs were played on 5 more commercials than movies. Which is the smaller group? The movies is the smaller group. Now, you might say to me, well, why do you care, Mr. Stailey, about the smaller group? Because I need you to realize that we need to do something to the smaller group to get the bigger group. So the smaller group is why we are going to add 5 to get the bigger group. Right? This is my bigger group. Okay. Well, now we got a substitution question, right? You're going to take this y plus 5. You're going to come over here and replace that. So 20 times y plus 5 plus 120y equals 380. Okay. 20y plus 100 plus 120y equals 380. Can't. Which would be, so if I put those two things together, that's 140y. If I take the 100 to the other side, I get 280. And then I can divide by the 140, divide by the 140, and find out that y is 2. So 2 movies. So how do I find the number of commercials? So now I got to plug it back in, right? And I think it's easiest to plug it back into this equation up here. X equals 2 plus 5, or 7 commercials. So 7 commercials and 2 movies. Now, on the next question, jar contains only nickels and dimes. We'll call the, whoops, come on, let's scribble. The nickels X and the dimes Y. Then it says there are 3 times as many dimes as nickels. So the smaller group is the nickels. And we're going to do something 3 times to get the larger group. Smaller group times 3 gets me the larger group. I promise you, if you identify which is the smaller group and then do something to it, you won't make a mistake. But if you forget to do that, you will probably write that equation backwards and say x equals 3y, and then the whole problem's over with. Now, the second equation is about the money. If the amount of money in the jar is $4.90, well, a nickel is 0.05 of a dollar. And a dime is 0.1 of a dollar. Now, there are some of you that do not like dealing with dollars. You are more of a penny person. Now, here's what I mean by that. Okay, you would rather deal with whole numbers. So, you like to multiply by 100, which gives me 5x plus 10y equals 490. You just like dealing with whole numbers. You don't want to mess with decimal points. Now, you can mess with decimal points. It's not a problem. But now we can take this 3x and we can drop it in the place of. So 5x plus 10 times 3x equals 490, which is 35x equals 490. And then if I divide by 35, on both sides, I find out that we get an x value of, I think it's 14. Let me just double check. Yes, 14. Okay, and so then I can plug it back in here. Obviously, very easy equation. 3 times 14 equals 42. So we have all the information we need. Nickels, we got 14 of those, and dimes, we've got 42 of those. Okay, that's enough notes and enough yawning.